So yes, so we have open SQL Server, Marine Studio, and here you have obviously like database. This is what we have seen before, and in database you have the one that we created, library database, right? And in library database you have database diagrams. Okay, you have tables, so open tables. Okay, right? You see this now. So these are the tables that we created, correct? What is index? Why do we use index?
Get the data easily.
Correct.
If we want to search something, then if we have index, then it will save the time for the system.
It makes searching fast. That's all. Okay. It makes searching fast. Okay. And the reason we create is okay. Now let's say if I go and expand student, let's say. Okay. So these are the columns, keys, constraints, triggers, and indexes you see. Okay. Okay. So see, it has already created an index, PK student. So I told you this is again type. There are different types of indexes. Okay, they're called as clustered and non-clustered indexes and filtered indexes. Okay, um, what is clustered index? Okay, by default, your primary keys they create clustered index. Okay, um, your clustered index is is more faster because it creates a physical table. Okay, so your clustered index creates physical table. Okay, and they reorder the content based on the indexed column, right? We always create cluster based on the column, right? So let's say by default on primary key the indexes are created. So if you have user ID, okay, it will manually sort in order of your column, right? So here it is called um, okay, primary key student. So this is students. If you go to column, which is our primary key, mem ID. Okay, so let's say you enter first mem ID 1 and then you enter mem ID 10. Okay, then you enter mem ID 5. It will move 5 before. Okay, so that's how it maintains that. Okay, first is 1, then 5, then 10. Okay, it maintains that order. So when you say find, okay, select star from this where mem id equal to 100, okay, it doesn't start from 1 to so on sequentially. It uses tree structure. It knows, okay, it starts with a mid value and then it sees where, let's say you have 1 to 500 and mid value is 200 something, 250, let's say. It will search, go to 200 and then say, okay, it is on left side of 250, okay, or right side of 250. So it will traverse that way, and then that way it is easier for it to reach to the right record. Okay. Um, so okay, so clustered index is always faster because it it takes all the data and reorders. Your non-clustered index, okay, will not rearrange all the data. It'll create another table, okay, where the memory location and the data will be created. And when you search for it, it will go and then see the information is in different place, okay, and the data is in different place. So based on the information, it will go and fetch the data. Okay, so that's why your clustered index is fast. It's like you're taking time to create clustered index. Clustered index will take time because it has to rearrange everything, the data. So it is faster to slower to create but faster to access the data. Okay, so understood that, right? In clustered index, okay, it sorts the table based on your prime or whichever column you are giving, you're creating an index for, right? So I told you, like, for primary key, you don't have to do it because automatically system will create primary key for, sorry, index for primary key. But if you are using some other column, okay, extensively, other than the primary key, okay, then it is always better that you create an index on that column too. So that's why, every database, okay, SQL or Oracle, every database creates index on the primary key. So you don't have to worry about creating index on primary key. But sometimes we use other columns also for searching, okay, navigating. There we need to create index on those extra column. Okay, so clustered index is uh, is 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 time consuming because it has to rearrange the entire content of the table, but it is faster. Non-clustered index, okay, will have, you create a table, normal table, that's fine, but the information about the index on the table will be kept somewhere else. So when you search for something, it will go and search the somewhere else, okay, figure out the location of the data, then come back and display. Okay, that's why it is little slower than clustered. But advantage here is that it is not time consuming. Creating index is easier, faster. Okay, so how do you create an index? Okay, so let's say this is your table, right? Index will be on table only. It is related to table. It can link to one column or multiple columns, right? So let's say if we talk about this index here, I say right click and new index. Now you see here, you have rebuild, reorganize, okay, disable, okay. So what could disable do?
It will not show.
No, no, no. Disable means that your index will not be available. Okay, so index is created, but when you perform, see, when does index is accessed? Index is accessed only as the search time. Okay,
Yes.
index is accessed only at the search time. Okay, so when I'm saying where, the moment you say where, it will look for, okay, it will look for an index. Is there an index? Moment every time you say where, it look for index, and if it doesn't find an index, then it will do the sequential search. Okay, so when you say disable, it is index is there, right? It's not deleted, but when it goes and search for the index, it will not find the index. Okay, so access becomes slow. So that's called disable all. Let's say you're doing some maintenance or something, you can say disable all for temporary. Okay, then you have a new index, which is obviously to create new index. But interesting thing here is called rebuild and reorganize. Okay, what is rebuild and what is reorganize? Okay, so as the name suggests, okay, you are rebuilding
Rebuild
the
means
entire,
reconstruct it again from the start.
yes, okay, okay, um, okay, and it could be your online or offline. In the sense, sometimes, okay, you are dropping the entire table. Like, say, if you are talking about non-cluster, okay, you will drop the entire the new table which is created and recreate it again. Now, why do we need to rebuild it? Okay, see, when you are performing only read operation, then you don't have to perform reorganize or rebuild. It's not required. But when you do a lot of write, right? So it's like, I don't know if I gave you this example before or not. When you are reading from a book, okay, your book will be very neat and clean when you're only reading it. But let's say you're making notes. You're reading and you're adding some notes. Let's say you're reading from somewhere else and you're adding. Now, when you start adding notes, okay, so the index of the book will only have the content which was, which was there originally in the book. When you start making some notes, this new note will not be included in the index, right? Then you go and change the index. So what happens here in the read when you perform insert, okay, not so much an update, but mostly in the insert, new records are getting created. Now, when new records are getting created, your original plan of sorting will get disturbed now, right? So you sorted, okay. Initially, you sorted all the data. You are happy. Suddenly, new data came in, so it will be added somewhere at the end, right? Now, so again, you have to build in such a way that that row is added in the beginning or in the as the actual place. So you have to rebuild the index, right? Or reorganize. So reorganize is much lighter. Okay, this can be done when your database is live. Rebuilding does when your database is offline. So so let's say if you are running your application, and every night you can reorganize your data. Sometimes you might have to take the database offline. Okay, so when you take offline, you are recreating all the rebuilding all the indexes. Okay, so organize will always happen online. Okay, your database will be up and running and still you can do organize. But rebuilding can also be done online, and also it can be done in offline. Okay, so why do we need to do or reorganize or rebuild?
Because if the content is updated, we may add something or we may delete something, then the numbers or the indexes may change.
Yes, when you make a lot of edits or insert into the database, it will impact the indexes, right? Because indexes is created based on the data. And when you edit the data, your data will no longer be on at the same place, right? So when you're performing search, okay, index after doing lot of, okay, one or two will not have much impact, but if you're doing lot of insert update, okay, after some time, sometimes your index becomes unusable. It is as good as not using an index. Okay, so index is there, but index is not serving. So it's going checking for the index. And let's say I ask you to go to tell me about some topic. So you go to index, and the topic is mentioned page number 60. You go to page number 60, but that information is not there. Why? Because you added some information before. So this went to page number 65, 75, 80 somewhere. You don't know where it is. But index is not able to help you. So now what will do? Again, you'll start from page number 1. So you tried searching using index. It took you some few seconds. You could not find it. So now you are going to sequential manner. So your index, we say, has become unusable. Index has become unusable. So to make index usable, we can use reorganize or rebuild. Okay, rebuild is like deleting the index and creating it again. Okay, so it can be slower, but the performance will improve drastically. Okay, so when you perform rebuild, performance will improve drastically. It's going to drop it. Now when index is dropped and that time some request comes in, that request is going to be very slow, right? Index is not there at that moment. So deleting and recreating might take, let's say, 5 minutes. So during that 5 minutes, your performance will be dead slow. Okay. So so that's why mostly we give a message saying that database is under, or we don't allow user to log in, recreate, but you can do it online. It doesn't have to be offline. Reorganize it as high level. Okay, so you don't have to take database offline. Okay, and as a user, they will not going to see much of problem in terms of reorganizing the database, but and it only looks at what you call as leaf node. I told you the structure is such a way that it creates a binary tree structure, right? It's only going to see that if the leaf nodes, okay, are in sequence or not. You're going to just change the leaf node sequence. It's not going to recreate the entire tree like rebuild. So rebuild will be time consuming, but performance will be drastically improving. Reorganize. Let's say you are facing some some performance issue and you cannot, it's peak hour. So at peak hour, you cannot perform rebuild, right? Because rebuild will then have a lot of negative impact. So in that case, you just do reorganize. At least some improvement will happen. And in the evening, in the night, when the traffic is almost zero, then you go and recreate. Recreate, we call it recreate or rebuild the index. Okay, so those are different options. Okay, so you are rebuilding it. That means you are dropping that index and creating it again. Now here we are going to create our own index, right? So when you say index here, so see, clustered, non-clustered. Now in this case, your clustered is disabled. Okay, why clustered is disabled? Can you guess? What did we say? What is cluster? We said cluster is physically organizing the data, right? So you have already physically organized the data based on mem ID, correct? Now how can you again reorganize, right? See, when you are doing physically moving something, you can move physically from one location to another location. Now, if I tell you to
Yes.
move from that location to somewhere else, then that location will not have, no, that
Yes.
location will not have, you're moving. So, but non-clustered, I said, the data is not moved. It creates new set of information which will point to the original location, right? So you can have only
Right.
one clustered index for a table. You can't have more than one clustered
Mhm.
index. And by
Okay.
default,
Right.
your primary key is clustered index. So, that will take care of indexing, right? So apart from primary key, okay, see, the reason we create primary key is because we expect that column to be used more often, right? We say in the examples that we did, right? Almost every time we used primary key only. Sometimes we used other columns. Okay, so if other columns are used often, that's when we create another index. And as I said, you cannot move the data multiple times, right? So that's why you can only create non-clustered index. Now you can give table name, you can give your own index name. Okay, it has taken its default, but you can change it. Okay, I can say uh, NC index, okay, students, and I can say column name. Okay, so I don't know, I forgot column. Yeah, name. Let's say I put name here. Okay, you can always say unique. Okay, um, and then okay, you say uh, add here, right? So add. Okay, so when I say unique, we only have uniqueness for join date and mem ID. Okay, now if I remove unique, then also, because why? Because in name we said null, right? Name has null. Now when name has null, then you can't use it for indexing, right? Because the most of values are null, there's no point of index. Null means what? There's no linkage,
No value.
no
Mm.
value. Okay, so you can say join date and say okay. So we are creating on join dates now. Okay, and you can say okay. So it created non-unique and non-clustered. Okay.
Okay. Mm, okay.
So what happens again? Non-cluster we know. See, non-unique. Okay. Yeah. So if you make it unique, it will make sure that values that you enter will be unique. If somebody tries to enter non-unique value, it will give error. Okay. When you say unique. Okay. So it will not
I mean,
accept.
in the same date, more than one student can join. So this
No, forget
anything
about
cannot
logic.
be
I'm not
unique.
talking about the logic. I'm talking about the non-unique. Okay.
Okay.
I'm talking about
Mm.
the non-unique. So non-unique will allow duplicate values, and unique will not allow duplicate values. So if you make
Okay.
it unique, okay, you can't have two values with same unique date. Okay. So when you, like, for example, if you expect the data to be, you can always create on multiple columns. Okay. So now if I go and say properties here, okay, and I'll say here add, okay, okay, let me remove it. I go and add, okay. So you can select multiple columns, right? So let's say join date and date of birth. These two together can be unique. Yes or no? Okay. So then you can say unique. Join date may not be unique, but join date and your birth date. That means no two people will join on the same day with the same date of birth, right? So
Mm.
we can create. Now
Maybe.
we have less data here too. Okay. So
Okay.
yeah. So but this is how you can. So now if you say rebuild, it is going to so offline on off online. Okay, we'll say online. That means your system is what is the error? So we will remove online and then say okay. So it will take the data of database offline, okay, rebuild it, and then bring it up again. Okay. We'll do a little bit of, maybe we'll spend one day tomorrow, we'll spend some time doing TSQL. TSQL is writing procedures and functions. Okay. That is like writing a complete Python program within SQL Server. So we'll spend one day just to tell you, what is procedure, what is functions, how to write procedure, how to write functions. Okay. It's called TSQL, and this is very specific. SQL is not specific to database. But PL SQL and TSQL are specific. TSQL is a language for SQL Server, okay? And PL SQL is for Oracle,
Yes.
okay? And here, see, SQL is only one line of command. But TSQL is multiple lines, just like Python program, okay? So it is like writing
Mm.
functions. Remember we wrote functions, def, function name in Python. Similarly, we'll have to write here.
Yes.
Okay, is equal. So we'll
Okay.
spend, and then maybe one day, 2 days we'll spend on data warehousing. and then we go to Power
Okay.
BI. That will be our last topic. Okay.
Okay.
So we'll stop here for today.
Yeah.
Yeah.
Okay, Swapnil.
Yep. And
Thank
tomorrow we'll practice some TSQL, and then we'll do data warehousing.
Okay. Thank you.
Thank you. Take care. Bye.